Basic log properties. Letting you know now that you will need to pause this video at several points along the way. Okay, first thing you must keep in mind is that a log is an exponent. Page 304 has all the properties that I'm about to list. You can pause along the way if you prefer. So what does this mean, a log is an exponent? Log form, exponential form. So general log form, and you may see it with different variables, but in the last video, I talked about how B is the base, A is the argument, and X is the result, the exponent, whatever. So the log base B of A is X. Well, here, when you change forms, the base to the power of X is equal to the argument. So these are equivalent forms. One is called log form, one is called exponential form. Well, if you take a look in exponential form, X is the exponent, X is the exponent, the log form equals X. What is X? X is the exponent. So the exponent is the same as the log. Okay, here comes the pause, all the log properties. I'm going to prove the ones that are starred. The most important of all of these properties is change of base. Arguably, I think it's change of base. We can prove everything using change of base. So I'm going to prove the two that are starred. I'm going to start with the log base B to the X power of B equals 1 over X. The base is B to the X of B. Okay, so using change of base, this becomes the log of B over the log of B to the X. Change of base formula, the log of the argument B over the log of the base B to the X. Okay, use the power property, probably the second most useful of all the properties. This becomes the log of B over X is the exponent, bring it down in front using the power property. X is the exponent, using the power property, the exponent comes down in front and becomes a coefficient. Well, the log of B over the log of B is 1. So when you reduce, you get 1 over X. Super helpful property if you can remember it. I'm going to do the same thing with the next starred property. And I don't know the names of these. If you remember these from Algebra 2 Honors, more power to you. Okay. This says the base of the base, which sounds weird, and the base of the argument are the same. You're left with exponent over exponent. The base of the log is B to the X. The base of the argument is B. Okay, so here we go. This is going to change a base. This is going to be the log of the argument, which is B to the Y, over the log of the base, which is B to the X. Argument B to the Y, the base B to the X. Change of base property. Power property, the exponent Y comes in front and becomes a coefficient. The denominator, X is an exponent, comes down in front by the power property. The log of B over the log of B reduces, and you are left with Y over X. I'm a firm believer that if you understand where the properties come from, no memorization is necessary. Okay, there are several ways that you can do this problem. They have the same base. They both have a base of 8. So using the quotient property, when you subtract logs, you divide arguments. When you subtract logs, you divide arguments. Don't divide logs, divide arguments. All right, well, 16 over 2 is 8. And the log base 8 of 8 is 1. If you don't like that, where did this come from? Again, you can use change of base to prove this. The log of the argument over the log of the base. Anything divided by itself is 1. Five to the log base 5 of 6. This whole thing is the exponent, plus the log base 5 of 7. So this whole log thing is the exponent. Okay, product property. Product property says if the bases are the same, you multiply the arguments. So I'll show that step. This is 5 to the log base 5 of 6 times 7. This is 5 to the log base 5 of 42. The base of the exponent's log base 5 of 42. The base of this exponent is 5. The base of this log is 5. They both have a base of 5. The answer is just the argument. Another super useful property. Okay, how about e to the log base e squared of 9? E to the log base e squared of 9. Okay, I'm just going to look at the exponent. So I'm just going to pull this off to the side. The log base e squared of 9. Well, that's difficult, but it's not. If you go back to one of the properties I proved, exponent is 2. This is the same thing as 1/2 the log of base e of 9. Property, the exponent of the base comes out as 1 over whatever that exponent is. So in this case, the exponent's 2, comes out in front as 1/2. So I have now e to the 1/2 log base e of 9. I'm digging this. Base is e, that's awesome, but I have this coefficient in front. So I'm going to do the reverse power property. This becomes e to the log base e of 9 to the 1/2. I took the coefficient and I brought it up. Normally we take the exponent and bring it down. Well, no one says you can't do that in reverse. Now, base of the exponent matches the base of the log. So this is 9 to the 1/2, which is 3, not 9/2. 1/2 is a square root. Okay, last ones. These are the kind of problems that I can use to assess your knowledge of logs without a calculator. So I would put a little star next to these to make sure that you know how to do them. I'm going to tell you that the natural log of 2 is some value a, and the natural log of 3 is some value b, and the natural log of 5 is some value c. You can find these on your calculator. I'm giving you that. There's some value, a, b, and c. So I want you to evaluate something like, so the directions will say this. Rewrite using A, B, C. So let's say I ask you to rewrite, find the natural log of 0.5. That's not point C. Oh, no. So I want to rewrite 0.5 using a combination of 2 and or 3 and or 5. Well, 0.5 is the same thing as 1/2. 1/2 is the same thing as 2 to the negative 1. You cannot substitute yet. If you substitute for a, natural log of 2 is a, and you tell me the answer is negative, or is a to the negative 1, that is not correct. You have to completely isolate the log. Use the power property, bring the negative 1 down in front. The answer is negative a. I took out the natural log of 2 and I put in a. You can't do it here because there is still an exponent attached to the 2. You have not isolated the natural log of 2. Here, you have isolated the natural log of 2. Let's look at the natural log of the 4th root of 2/15. There's a couple ways you can do this. I'm going to rewrite the 4th root as the natural log of 2/15 to the 1/4. 4th root, 1/4. 1/2 root, 1/2 power square root. Okay, this is the same thing as bring the 1/4 down in front times the natural log of divide argument, subtract logs. Divide the argument, subtract the logs. Okay. Now I have awesome. The natural log of 2 is a. Cool. 15, yeah, 15, 3 times 5. So this becomes 1/4. The natural log of 2, be careful, minus the natural log of 3 times 5. Okay, multiply arguments, add logs. Multiply arguments, add logs. You do not need to show all of these steps. So this is minus the natural log of 3 plus the natural log of 5. Multiply arguments, add logs. Here, divide arguments, subtract logs. Now I can substitute. So this is 1/4. The natural log of 2 is a, minus the natural log of 3 is b. If you distribute, this becomes subtraction, minus the natural log of 5, which is c. This is a true test of knowing your properties. One last quick side note, if you're confused about how did I go from the 1/4 power to, or sorry, the 4th root to the 1/4 power, x, helps if the marker works, x to the m over n is equal to the nth root of x to the m. The denominator is the root, also known as the index. Denominator is the root. Numerator is the exponent.